Hello everybody. So this video is here to talk about the strategy of implicit differentiation. Okay, and what implicit differentiation is this is a powerful strategy that shows us how do we take a derivative of an equation that's not a function. So if you have an equation with x's and y's, but you can't write it as like a y equals something, you can still take a derivative. And of course, when we're talking about derivative, we're interpreting that as the slope of the tangent line, which we refer to, of course, as dy over dx. Okay, so let me give an example of this. So suppose I tell you x squared plus y squared equals 25. You should recognize that, of course, as a circle and with radius 5. And I ask you to find an equation for dy dx in terms of x and y. Okay, so here's what you're going to do. There are a couple of steps to this. And the first thing you're going to do is you're going to take the derivative of both sides. Take the derivative of both sides. And then just using all the normal rules, so we're going to do the normal rules, but the only kink is that when you differentiate a y, because of the chain rule, you're going to have to multiply by, when you differentiate y, you multiply by a dy dx. So basically what we're doing is we have this equation, we're taking a derivative of both sides. Derivative of x squared is 2x. Derivative of y squared is 2y, and then by the chain rule, it's like y squared, so the 2y comes down, and then we multiply by the derivative of y, which is dy dx. The derivative of 25 is 0. So once you've taken the derivative of both sides, that's kind of your first step. Your second step is just to solve for solve for dy dx. So in this case, we'll say 2y dy dx equals negative 2x, so my dy dx is equal to negative x divided by y. Okay, and that's what you've done. So you have, again, this is a formula for the slope. So if the problem needed us to find like the slope at the point, say 3, negative 4, that slope would be equal to, at that point, dy dx equals negative 3 over negative 4, which would be 3/4. Oops. So again, it's a way that you can find the slope at a point x, y. Okay, so that's what we're trying to find. Let's go ahead and do a couple more examples like this before we get into anything super crazy. So let's say we have y to the 4 plus 3y equals 2x cubed minus 1. If you want to pause your video and try this out on your own and see if you match my answer, that might be a good idea. So let's go ahead and get started then. When we take a derivative of both sides with respect to x, the derivative of y to the 4 is 4y cubed times the dy dx, derivative of y. Derivative of 3y is 3 times the derivative of y. So every time you differentiate a y, you need a dy dx on each one. Okay, and then the right side, the derivative is 6x squared. Now you might be asking, well, why don't we have a dx or something on the other side? Well, let's think about that, right? First off, what would dx over be? Well, you can kind of see from the notation, dx is just 1, right? So multiplying by 1 doesn't really do anything. Another thought is like you could say, you multiply by the derivative of y, which is dy dx, but you multiply by the derivative of x. Well, the derivative of x is just 1. Okay. So once you're at this step and you have 2 dy dx's, you might be a little confused, but what I want you to do is to factor out the dy dx. So when you factor out a dy dx, you're left with 4y cubed plus 3 equals 6x squared. And then in our last step, when we solve for the dy dx, we'll end up getting 6x squared divided by 4y cubed plus 3. All right, so that's kind of what's going on there. Let's look at another example with some weird functions. Say we have tangent y equals e to the 2x plus y squared. So here we kind of have a y on both sides. And again, this problem is asking me to find the dy dx here, so let's differentiate both sides. So the derivative of tangent becomes secant squared y times the derivative of y. Derivative of e to the 2x is e to the 2x times 2. Derivative of y squared is 2y times the derivative of y. Okay, so let's get all the y terms on one side. So we get secant squared y dy dx minus 2y dy dx equals 2e to the 2x. One of the beautiful things about the chain rule is you will always, always, always be able to factor out a dy dx eventually. Like you're never going to get stuck with too many or something. Anyway, so once you factor that out, you got a dy dx here and then here because both those terms had a y. You again solve for the dy dx, which is 2e to the 2x over secant squared y minus 2y. Okay, so there's your problem. Let me show you a couple other things here. First off, I want to show you a shortcut if you have to find dy dx at a point. So suppose I ask you this. Suppose I say 6 plus x cubed y equals sine of xy plus 2x. And I ask you to find the dy dx, the slope of that tangent line at the point 3, 0. So again, this is just the slope of the tangent line at that point. So these functions might not pass the vertical line test, they might overlap, but this just tells you to find the slope at that particular point right there. All right, so keeping that in mind, let's go ahead and start by taking a derivative. Well, the derivative of 6, of course, is 0. When you do an x cubed times y, you have to do the product rule. So you have x cubed times the derivative of y plus y times the derivative of x cubed, 3x squared. On the right side, things get gnarly, right? So when you take the derivative of sine of xy, you get sine of xy. But then because of the chain rule, you have to multiply by the derivative of xy. So we have x times the derivative of y plus y times derivative of x. The derivative of 2x is just 2. Now, you might think, you could solve for dy dx here. And I'll leave that as an exercise to you. If you feel particularly bored, you have to distribute this out and then combine terms, give everything one. It's a total mess. The other thing you can do, and this is the shortcut, is you could just plug in 3, 0 here. You've already taken the derivative, right? So if you've already taken the derivative, it's a lot easier to just plug in that 3, 0 here. So when I do that, I'm going to get 27, 3 cubes 27, dy dx, plus, okay, this term is a nice, okay, equals, let's see, the sine of xy. So that's the sine of 0, which is 0 times, who cares, times 3 dy dx. Here's why I screwed up. The derivative of sine, of course, is cosine xy. I apologize for that. So this should be cosine of 0 times 3 dy dx plus 0 plus 2. So anyway, what you'll see is you'll get 27 dy dx equals, this is cosine 0 is 1, so this is just 3 dy dx plus 2. So I'm going to get 24 dy dx equals 2, so dy dx equals 2 over 24, or 1/12. Now, this obviously wasn't beautiful, but this is a great shortcut that you can use. I didn't have to solve for the dy dx. It was just faster to plug in now, as soon as I've taken the derivative at this point, and get my answer. Okay, so that's about it with that. Let me show you one more, just a reminder of some stuff that you may or may not have learned in Algebra 2. So say I tell you that x squared y squared minus xy plus 3x equals 3. And I ask you to find the points on the curve with x equals -1. Now, I want to ask you anything. Does this say anything about slope? Right, there's no mention about slope at all. So we're not going to actually find dy dx. This is an equation for the curve. When you find dy dx, that gives you a slope. But if you just have an equation in terms of x and y, that's just talking about the curve. So what I'm going to do is let's just plug in the x equals -1, and then that's going to solve for y. If the question is asking me to find points on the curve, they're asking me to find x, y, things in that form. So let's plug that in. So I plug in -1, so I'm going to get y squared plus y minus 3 equals 3. Okay, so I'll subtract over, so y squared plus y minus 6 equals 0, and then I can factor out to y plus 3, y minus 2 equals 0. Okay, now I need to have points, so I have the y equals 2 and -3 here, but my points are going to be -1, 2, and -1, -3. I need to use this x value as well as the y values. Okay, so that's how we answer a problem like this. So there was an AP question a couple years ago that said something like this. It was like y squared plus cosine y equals x minus 2. And it says, find the slope of the line tangent to the curve at y equals 0. Well, this is like a two-step process, right? First off, you should find the point. And then once you find the point, you will find the slope at that point. Okay, so when I go ahead and first off find the point, so I plug in y equals 0, So I'll get 0 plus cosine of 0 equals x minus 2. So 1 equals x minus 2. So my x is 3. So then we have the problem 3 comma 0. Okay, and then from here it's pretty straightforward, right? We find dy dx, and then we plug in 3 comma 0. So that's just your strategy. Find the point first, and then follow the steps from before to find the slope. Okay, so that's implicit differentiation. Thanks for watching. I'll have more in the next video.